Before that, I just want to tell you, just because something is difficult doesn't mean you shouldn't try it. It just means you should try harder. So everything is achievable in life if you try harder and harder for that. Whatever you want in life, you can just get it. So let's come to conic sections. Now, suppose, now this is a pen. All of you know that this is a pen. Now, what I'm doing is I'm just fixing this point of the pen, right? Let's take this point. I'm just fixing this point and rotating this about the fixed point, right? Rotating it about the fixed point. So what type of figure? If you look here, let's take a thin pen. If we are taking this and rotating it about the fixed point like this, I'm rotating it about the fixed point. What type of figures are we getting? What type of figures are we getting? Can anyone tell me if I rotate it like this? This point is fixed and we are rotating the pen like this. What type of figures are we getting?
Ma'am, cone.
Cone. We are getting two cones, one at above this point and one is below this point if we are rotating it, right? So this is how we have got a cone. We are taking a line, let's take a fixed point here, and we are rotating it about this fixed point. And when we rotate it about the fixed point, we are getting two cones about this fixed point, right? And they will be like this. We are getting a circular part here, cone is like this. We are getting another part here. The fixed line that we were taking, the pen that we were taking fixed when the position was fixed, that is the axis of the cone. When the position was fixed, that is the axis of the cone. Now when we were rotating it about this fixed point is vertex of the cone. This fixed point is vertex of the cone. And whatever line, when we were moving the pen, whatever line is generating the cone, whatever line is generating or making the figure as a cone, whatever line is generating the cone, that is the generator of the cone, right? So the fixed point is the vertex, the fixed pen, the fixed line is the axis. When we were moving the pen, then there was a line which is the generator of the cone, which was making the cone after we were moving that. So that is the generator of the cone. Okay. So these three things we are having here, and we know we are having two cones here, and these two are termed as naps. NAPPES. These are naps of the cone. So it is a double napped cone. Two naps are there, right? One is above the vertex, other is below the vertex. And when we are talking about conic sections, let's take the angle between generator and axis as alpha. The angle between generator and axis as alpha, right? So this is all about how we are getting a cone. Now, after we have got a cone, we have to study about the various conic sections. Now, how do we get these various conic sections? For that, we are intersecting the cone by a plane surface. How do we get different conic sections? We are intersecting the cone by a plane surface. Okay, what do we do? Let's take a cone. I'm making another figure so that it will be more clear to you. This is axis of the cone. It will be in the middle. And we are intersecting the cone by a plane surface, right? Any plane we are having here. And this plane everything that we have has an axis. So this is a plane. It will also, the angle between cone and generator was alpha. And another angle we are taking, that is, this is the axis of the cone, this plane surface. This is axis of the plane surface, and the angle between both the axes, the angle between, let's take this as alpha, we are taking Okay, this is alpha. The angle between both the x's we are taking as beta. Okay, the angle between axis of cone and generator. This was the angle which is alpha. The angle between axis of plane and axis of cone we are taking as beta. Now various sections of cone depend upon this angle. At what angle this plane surface is intersecting the cone. Various sections of cone depend upon this. So I'm just giving you when the different cases, and then we will see that how are we getting these different cases. So different cases, yeah, values of beta for different sections. Let's take about sections of cone. First one, when beta is equal to 90 degree. That means when the plane surface is intersecting the cone at 90 degree, let's see what we get. We will just check it. Secondly, when beta is greater than alpha and less than 90, that means it is an acute angle like this. This type of angle we are having. Then what do we get? We will just check that. After that, the third case is when beta is equal to alpha, when both of the angles are equal, then what do we get? And the fourth one is when beta is greater than equal to 0 and less than alpha. So these are the four cases where we are having four sections of the cone. Now let's see how do we get these four sections. Now, this is a cone that we have, and this is a plane surface, right? A cone and a plane surface. Let's intersect it. Okay. Now, if you look here, I'm just showing it like this. If you look here, the plane which we are intersecting is at 90 degree, right? Is at 90 degree to the cone. What type of figure are you seeing that you are getting at the plane surface? What type of figure will be there at the plane surface if it is intersecting the cone at 90 degree? Can anyone tell me what type of figure are we getting at the plane surface if we are intersecting it at 90 degree? Can you look at the figure?
Circle.
Circle, because the base of this cone is a circle. So if we are intersecting it at 90 degree, we are getting a circle, right? So this is one of the sections of a cone. That is, when the angle is 90 degree, we get a circle, right? When cone is intersected at 90 degree, we get a circle. Now let's see if we are intersecting this at less than 90. Less than 90 means we are somewhat tilting this. Okay, we are somewhat tilting this and we are intersecting it at less than 90 like this. Like this, if we are intersecting, let's see what type of figure. It will cut at some part of the circle. We will get this type of figure. Let's see what we are going to get. Just look here. We are intersecting it at somewhat tilted type is there, like this. Somewhat tilted is there, right? This way. What type of figure are you getting at the plane surface? It's somewhat tilted. What type of figure are you getting? Ellipse. It is an ellipse, right? We will get, because it is tilted, it's not like this now. I have cut some portion from here, it is tilted now, so we get an ellipse. So when beta is greater than alpha and less than 90, we get an ellipse, right? Let's come to the third one. When beta and alpha both are equal, that means somewhat more tilted, right? So what will it do? When both are equal, it will cut like this, such that some more we are taking A bigger angle, which is, it is greater than alpha but less than 90. So beta was greater than alpha here. Now we have just made it equal to alpha. Okay, we have made it equal to alpha. So some more tilted type of portion will be here. That means it will not cut the whole cone. It will cut it like this. It will cut it like this, right? When it will be on the surface of the cone, so it will cut it like this. What type of figure are we getting then? If we cut it,
parabola.
हाफ दिखाई देगा हमें सिर्फ, ठीक है. व्हाट टाइप ऑफ फिगर आर वी गेटिंग, क्योंकि इस तरह कट होगा तो इसी तरह की फिगर हमारी ऊपर ऊपर वाला जो पोर्शन है, वी विल गेट दिस टाइप ऑफ फिगर. जस्ट आई एम जस्ट टेलिंग यू व्हाट we will get this type of figure, right? ये कट हो रहा है पोर्शन इतना, तो we will get this type of figure which is a parabola, right? So when beta is equal to alpha, we get a parabola. And then the next case, और छोटा कर दिया हमने एंगल, ठीक है. सबसे पहले it was greater than alpha, then it was equal to alpha, then it is less than alpha, और छोटा कर दिया हमने एंगल, तो और ज्यादा टिल्ट हो गया ये. और ज्यादा जब टिल्ट हो जाएगा तो क्या करेगा, it will move, it will just go inside this cone, it will cut the other nap of the cone also. It will cut the other nap of the cone also. That means it will be like this. Is that the plane surface will be like this, and it will cut both the naps. So we will have a figure which is of this type, which is of this type. This type of figure will be there on the plane surface. That means double parabola, and this is a hyperbola. So when again we just make the angle which is less than alpha and greater than 0, so this will cut both the naps of the cone and we will get a hyperbola. Right? So this is how we are getting, is it clear to all of you? Is it clear to all of you? How are we getting various sections of the cone? When we are cutting the naps of the cone at different angles by a plane surface, or when we are intersecting a plane surface at different angles to the cone. Different angles to the cone means the angles are between the axis of the plane surface and between the axis of the cone. Then we get different sections of cone accordingly when the angle beta, that is angle between axis of cone and angle between axis of plane, that is 90, we get a circle. When it is greater than alpha, less than 90, it is an ellipse. When beta is equal to alpha, we get a parabola. And when beta is greater than equal to 0 and less than alpha, then it will cut both the naps of the cone and we will get a hyperbola. Right? So this is how we are getting different sections of cone. Okay, so that is why the name of the chapter is conic sections. We are intersecting plane surface with this cone and we are getting various sections here. Okay. Now, after this, we are having some degenerate cases also. That is, when the plane cuts at the vertex of the cone, we have following cases. Now, these are when the plane is cutting at the different cusps, or we can say naps, either cusps or naps. So we are getting these sections. Plane may cut at the vertex also, right? Plane may cut at the vertex also. So when, if plane cuts at vertex, so we get degenerate cases. Degenerate cases means nothing, no type of figure will be generated there, right? So these are degenerate cases. What we will get is when beta is less than equal to 90 and greater than alpha, we get a point. When beta is equal to alpha, we get a straight line. So you just have to remember these things. And when beta is less than alpha and greater than equal to 0, we get a pair of straight lines. Now, this was the case when beta is both of these. In both of these cases, when it cuts at the vertex, so we get a point. In case of circle also, in case of ellipse also. When beta is equal to alpha, we are getting a parabola. Since it will intersect at one point, it is intersecting at the vertex, not at the cusp. So we will get on single side, we will get a thing there that will be a straight line. And when it is intersecting at both the vertices, right, at the upper part also of the vertex, at the lower part of the vertex also, so we will get a pair of straight lines. So these are the degenerate cases, right? That means we will not get any type of section of a cone since it is intersecting at the vertex. So either we'll get a point or straight line or pair of straight lines. You just have to remember this, that at what angles, or you just have to understand this thing, that what figure we are getting accordingly. Okay, now we will be studying about these different sections one by one. And first of all, we will be taking circle. Okay, we'll be taking these different sections one by one. First of all, we are going to take circle. So let's take a circle first. Can anyone tell me about the definition of a circle? You are studying circle from very beginning. Can anyone tell me what is a circle? How can you define a circle? Yes, anyone? How can you define a circle? If I ask what is a circle, so what can you say about a circle? No one knows what is a circle?
Ma'am, proper definition.
Kuch bhi, whatever you understand about a circle. Anyone just can tell, whatever you understand about a circle. Yes?
Ma'am, a circle is defined as a locus of a moving point from a fixed point.
Okay, very good. Very good. Locus. Now we have used a word locus. What do we mean by locus?
Ma'am, locus is a point which satisfies every condition of your line.
Locus is not a point. Locus is path. Path traced by any point, right? Locus is path traced by any point. So what you said is circle is locus of a point which is equidistant from a fixed point. Let's just see. We are having a fixed point in a circle. Let's take a point here and we are tracing the path of this point A such that it is at a fixed distance from point O, right? We are tracing the path of this fixed point A such that it is at a fixed distance from point O. So let's just trace this point. A is moving such that it is at a fixed distance from O. So A can move in along this path. A can move along this path, right? Always this distance OA is fixed. And when we are tracing this path, we get a circle. And this is what we say, it is locus of point which is at a fixed distance from a fixed point. Locus of point which is at a fixed distance from a fixed point, right? So this is a circle. So a circle is set of all points in a plane that are, or we can also say a circle is set of all points in a plane that are equidistant from a fixed point, right? And this distance we say as r, which is radius of the circle, fixed distance. And this fixed point is center of the circle, right? Fixed distance is radius of the circle and fixed point is center of the circle. And this is any moving point on the circle. We take its coordinates, general form, we take the coordinates in general form as x and y. Any moving point on the circle, we take the general coordinates as x and y. And since this is the circle, in general, we take the circle. If we are moving it on a coordinate x, if we are taking it on coordinate x's, we take, let's take the center at the origin. And when we are, okay, this is a particular case when we are taking it at origin. Let's take some general points first. Let the center be at HK. Let the center be at HK. Now AO is a straight line. You know the distance also. So we can apply our distance formula. That is under root x minus h whole square plus y minus k whole square. You know that distance formula, x2 minus x1 whole square plus y2 minus y1 whole square. And this AO distance is r. So r equal to x minus h whole square plus y minus k whole square, and squaring both sides, we get the equation of circle as this one. That is x minus h whole square plus y minus k whole square equal to r square, where hk are the coordinates of center and r is the radius of circle. Right? So general equation of circle is x minus h whole square plus y minus k whole square equal to r square. And we have a particular case also if we are taking the center at the origin. Particular case. Particular case if center is at origin. So if center is at origin, coordinates of HK will become 0, 0. Let's put it here and we get the equation as x square plus y square equal to r square. Okay, so we get the equation as x square plus y square equal to r square. This is the particular case when center lies at origin. So we get the equation after putting hk as 0, 0, we get the equation as x square plus y square equal to r square. But in general, we will use this equation for whatever coordinates of center are given, we can take that. And the equation will come in terms of x and y, which is any general point on the circle. Okay, we'll be given the values of hk, we'll be given the radius, and accordingly we'll be solving other questions also. But the equation of circle will be in terms of x and y, which is a general point on the circle. Okay. So let's, this was all basic about the circle, and now we are taking some questions on that. One more equation we have. So in this case, if the equation is in this form and you are asked to find out the coordinates of center and radius of the circle, so this will be hk and r. But one more equation we are having, I'll just be giving you that also, if the equation is in that form. Another type of equation of circle that we have, if we are expanding this by opening the whole square. If we are expanding this by opening the whole square, we get the equation as x square plus y square plus 2gx plus 2fy plus c equal to 0. This is the general form. We have just changed our constants here, or coefficients of x and y. So this is also one of the general forms of equation of a circle, where the perfect square is not there. Either what you can do to solve it, either you can convert it to a perfect square, or from here also we have the coordinates of center as minus g minus f, and radius is g square plus f square minus c, where g we are taking 2g as coefficient of x, 2f as coefficient of y, and c is the constant term. You can compare the coordinates accordingly and you can get the values of g and f. So the coordinates of center from here, no need to convert it to a perfect square. You can just apply this directly also. Or the other way is you can convert it to a perfect square and apply the equation, general equation that we have just studied, x minus h whole square plus y minus k whole square equal to r square. When we are going to do a question, I'll take one question and do it both ways so that you can understand it both ways. So here the center is minus g minus f and radius is g square plus f square minus c. Okay, so and let's compare them. Or we have studied x minus h whole square plus y minus k whole square equal to r square. So here the center is h comma k and radius is r. Okay, and if we have the equation as x square plus y square equal to r square, so center is 0 0 and radius is r. Okay, so this is how we have just compared all the cases. First two are the general ones and third one is the particular case. If center lies at origin. Now, let's come to a question based on this. We are taking a very simple question of exercise 11.1. Let's take first question. What we have to do here is we have to find out the equation of circle when center and radius are given to us. Okay, we need equation of circle. So let's just take it. Let's take second question. The center is minus 2, 3 and radius is 4 units. So we just have to put it in the general equation. The general equation was x minus h whole square plus y minus k whole square equal to r square. Let's put the values. The value for h will be with the sign. So x minus, h is minus 2 here, okay, whole square. So either you can write it like this or you can just take minus minus plus. So we will have x plus 2 whole square. Y minus, the value of k is 3 whole square equal to r is 4. So before putting the value, you can just write here so that you do not make any mistake. H equals to minus 2 and k equal to 3 and r equal to 4. Now we don't have to leave the result here. We just have to open the perfect square and solve this. So x square plus 4 plus 4x plus y square plus 9 minus 6x equal to 16. And we will give the equation as x square plus y square plus 4x 6y. This is plus 13 minus 16 equal to 0. And we have the equation as x square plus y square plus 4x minus 6y minus 3 equal to 0. This is the required equation of circle. You will not read the result here. You have to give it up to this equation, right? So this is how we have to solve for the given center and radius and find out the equation of circle. So all the questions from 1 to 5 are similar. You are given the center and radius and you have to find out the equation of circle. Now, any problem up to here, what we have studied, you've understood about different sections of cone, how we are getting a cone, how do we get different sections of a cone, and then from those sections we have studied about one of them, that is circle. What is a circle? How do we get a circle? What are the general equations of a circle? And what is the particular equation of a circle when the center lies at origin? Then we have done one question based on that, that if center and radius is given to us, then how to find out the equation of circle, right? And we will continue it tomorrow, taking other questions based on circle. If equation is given, how to get the coordinates of center and radius, how to find out the radius. So rest we'll be taking tomorrow from the same exercise. And if you have some problem, just go through it. I'll be sending you the notes. Just go through it. If you have some problem, we'll be discussing that problem tomorrow. Anything else that you want to ask? Okay, so I'm just ending the session. Thank you. Have a nice day.